Hi, this video is about health information exchanges, or HIEs, and specifically how HL7 FHIR works with HIEs. This is by no means an exhaustive video on HIEs. It's just meant to actually promote discussion for one of the classes. Okay, what are we going to go through today? We're going to go through the components of an HIE, a master patient index, code mapping, storage, and record locators. We're going to talk a little bit about different systems, HL7 for all of them, version 2 for some messages, clinical document architecture or continuity of care documents, which are based on CDA, so CDA and CCD. We'll talk about HL7 FHIR as part of an HIE, and then we'll talk through some of the HIE architectures, centralized, distributed, and hybrid. So components, there's some things that you need to make an HIE work. It's not just a matter of storing data. The first is a master patient index. In the United States, as you are probably aware, we have no master patient index. There are other countries which do in fact have MPIs and are able to locate records throughout states or jurisdictions or countries, and they seem to work quite well. When you come to how do you create a master patient index, you are going to have, it's basically a table with a bunch of different columns. And usually the columns are associated. So you'll have an internal reference for an HIE, and it's some number, usually some integer. Maybe it's a unique ID, a global unique ID. That's what I would do personally, but it doesn't have to be. You can have an assigning authority. So you'll always have an assigning authority and a local patient identifier. So we've got a couple different healthcare systems in our HIE. One is St. Joe's, the other is Memorial, and another is Keystone. So this internal reference will identify this patient identifier at St. Joe's and this patient identifier at Memorial. For a different person or a different internal reference, so this is the second person listed in our HIE, they've been seen at Memorial at this using this patient ID and at Keystone using this patient identifier. And this table could have many, many more columns in it. So how do you get to those columns? How do you build that table? You use heuristics. So when you get information on a patient, you're going to get a patient name, maybe a social security number, address, and phone number. And that's some of the magic that goes on behind the scenes to do patient matching. There's all different sorts of heuristics which can determine percent confidence. And so it's a match or it's not a match. Some MPI algorithms have fuzzy gray areas in between, which they allow administrators to go through and correct. Some don't bother with that because very few administrators actually do it. I'm going to ask you to go ahead and take a look at the FHIR operations to see which of those operations may in fact help with the master patient index. Another component of an HIE is code mapping. Often EHRs will have local codes. For the HIE to be able to respond to queries, you're going to have to take those local codes and be able to convert those into standard codes. So hopefully the local code will get turned into LOINCs, NOMED-CT, ICD-10, whatever. Another option is if no codes come in with the incoming data, perhaps you can add a code. Other components of an HIE are storage. There's different ways to send information to an HIE. One of them is to actually send the data, for example, an HL7 ORU message. So it's a lab result or a CBC blood count. And you're going to send that HL7 ORU message, which includes the patient ID segment and all of the contents into the HIE. So the entire message with all of the data as a composite object is going into the HIE. Another way is to send what's called a record locator. And we're not going to get into IHE XDS because it's yet a whole nother world. But there's a way from this healthcare system to tell the HIE, hey, this patient has been seen at my hospital. Or maybe, hey, this patient has been seen at my hospital and I have some lab values for you. Or even, this patient has been seen at my hospital and I have a CBC blood count lab value for you. But not moving the actual information to the HIE, just the fact that the record exists. So the response to an HL7 ORU message is just an ACK saying I got the message. If you need the information identified in the record locator, you're going to query this system and actually pull the information back to the IHE. The first option is much faster, but perhaps more risky. The second option is going to impede in performance. Perhaps it's more secure. HIE storage can get to be fairly massive, especially depending on how many healthcare systems are part of the HIE. What standards does an HIE use? It's going to use typically HL7 version 2, especially ORU message or results messages, perhaps ADT messages, admission transfer messages. It's going to use something that we haven't really talked about too much in this class, and hopefully we will not ever offer a class on it, but it's called HL7 version 3 Clinical Document Architecture, CDA format. The CDA format is based in XML. The information model, the reference information model, is extremely difficult to understand, in my personal opinion. And CDA has been used between EHR systems to transfer information without really using the transport mechanism, just the reference model and the data. And it's time perhaps to move to another standard. We've learned in this class quite a bit about HL7 FHIE, and specifically the option to query for the prior clinical data set or for the full patient record. Please go take a look at the FHIE operations, specifically the patient everything operation. We're going to talk very briefly about HIE architectures. So any architecture that we talk about requires a master patient index, and it requires code mapping components. All right, central. All the data is sent to a large repository, typically via HL7 or CCD or CDA, to the IG server. Very, very large data stores. You better get your data accurate, but you usually get good performance. Distributed. None of the data is sent to the HIE. Only record locators are required. You can federate HIEs together using this distributed method. For that, see TEFCA and the QHINs videos. Distributed HIEs sometimes use FHIE queries and FHIE operations. You know where to find the data, you do not copy the data. Performance can be, let's say, variable. Then finally, we have hybrid architectures, and hybrids are combinations of centralized and distributed, depending on what the source EHR system is. And we're going to take a look at this in more detail. Okay, over here on the left-hand column, we have sources. Over here on the right-hand column, we have consumers. Typically, healthcare systems are going to be both sources and consumers. So we're going to follow these numbers. And by no means is this a thorough systems architecture diagram, and there's always other steps involved. But just to kind of summarize and ridiculously oversimplify, we have a couple of different healthcare systems. We've got Memorial Healthcare System and St. Joe's Rehab Hospital here, and they're based on HL7 version 2. And they're going to be sending ORU messages. Typically, they can also send ADT and other messages, but they're going to be sending HL7 version 2 messages in their entirety, including all the data to the HIE. This is really pretty common. Then once all that data is there, the HIE is going to have an input module, and that input module can consist of taking the messages and mapping them to an MPI so that the HIE is able to map information from both Memorial as well as St. Joe's to the same patient. Also, as part of this input module, there's going to be a code mapping algorithm. We're going to go through and take any local codes, either from Memorial or St. Joe's, and they're going to map them hopefully into LINC and SNOMED and ICD-10 so that they can find the information again later when they're actually looking for it. All right, so we're step 4. Urban Hospital is unaffiliated with these two, and they're not going to send all the data. That's just not within their domain and policies. So they're going to send record locator messages. This can be done in a variety of different ways, and we're not going to get into this in detail, but suffice it to say that there are standards for this, and it works. And we're going to just tell the HIE that this patient exists. However, once you do that, you still have to go through the MPI matching, because this is still going to be a local medical record number or local patient identifier. We'll know the assigning authority is Urban Hospital, but this needs to get mapped into that column as a new column in the master patient index table. And we're still going to have to go through number 6 here. We still have to go through the code mapping algorithms and make sure that any local codes, or perhaps, there's code hierarchies. So maybe they'll add some additional codes and code hierarchies to this so that the information is more identifiable and findable. Okay, now we've gone through all of the sources. Our HIE is sitting at a quiescent state, and we're just waiting for someone to come along and use it. Meanwhile, at a different date and time in the future, a patient arrives at Memorial Healthcare System. The physician, perhaps it's the physician in charge of transfers, is going to do a query to the HIE because they know that this patient has been seen, or they suspect maybe that this patient has been seen at other institutions throughout their state. So they're going to do a query, and maybe it's an HL7 fire query to the Health Information Exchange. Once that happens, we have to go through the MPI again, because remember, we have to map it back to this unique identifier or the master reference ID in the HIE. And then step 9. Then the HIE is going to gather all of the information that it knows. It may, if it came in via an HL7, it's already got that HL7 ORU, it's already got the information. If it is part of a record locator system, it's going to have to go out and query this information, get the response back. And then it's going to have to go through and create all of that information into a FHIR bundle. I see now that my numbers are inverted. It's going to put all that information either into a FHIR bundle or create a CCD or continuity of care document, which it will then send back to this, which requested the information. This is the system architecture diagram that we're going to go through in our discussion in class. Thanks, and have a great day. Talk to you soon.